Hello students, our new topic is the propagation of error. Okay, propagation of error, basically how does the error moves in an experiment. It is all about that. Okay, in the last class we discussed that in any experiment there will be some error, right? Then the way to get the minimum error, which we called it by a true value, that is by taking the mean of it, right? Now when an experiment is involved, it involved the measurement of two three physical quantities, right? Like simple, like suppose I need to measure the area of the of a block. Okay, then what I need to do, I need to measure the length, then I need to measure is breadth, right? So two measurement is involved. Then what? I need to multiply it, isn't it? Similarly, if I want to find out its perimeter, then I have to measure the length, I have to measure its breadth, and I have to multiply it by 2. So here it involves the measurement of two quantities, right? It involved the operation addition, it involved the operation multiplication. Now in different situations, when it involved the measurement of quantities 2-3 times, how will the error will going to propagate? It is all about that. Okay, the number one, we'll start when it involve. Okay, when it involve, it's given there properly in the note, when it involve addition. Okay, let's say when it involve addition, like addition is means what? Suppose you need to find out the perimeter, then what do you need to do? You have to do the addition. You need to measure the length, you need to measure the breadth, right? And you need to add them. So length measurement will have some error, breadth measurement will also have some error. Error and error, how it will mix up, it's all about that. Okay, so x, say addition is, let's say a plus b, the operation is addition. Okay, now in error analysis, you see one thing you need to remember, any reading, okay, any reading we write it this way, any reading we write it this way. Okay, this is a we write it this way, like z plus minus delta z, this way we write it always. Okay, if it is a, then a plus minus delta a. Why it is so? There is a reason. Okay, where a is the true value, delta a is the maximum possible error. Okay, maximum possible error. Like suppose, okay, I just take into example, you all of you are familiar with the centimeter scale, right? Now suppose I have a block and its length you are measuring by at a centimeter scale. Okay, then you measured this length by means of a centimeter scale, and the reading of it came in between, let's say 5.7. okay, the reading came as 5.7. okay, now the uncertainty, okay, in the reading can be by what? Plus minus 0.1, because what, in centimeter scale, what, there are small divisions, right? The smallest division is how much? 0.1 centimeter, right? So the maximum reading of that 5.7 which you have counted, maximum possible reading can be 5.8, and minimum is what, when you subtract it, 5.6. that means the real value of your experiment, which you have measured 5.7 by using a centimeter scale, is in between 5.8 to 5.67. Now if you had used a better instrument than the centimeter scale, then instead of just 5.7, because 5.7 has the significant figure of just 2 only, right? But if you could have used a better instrument, then it could have given a better reading, like up to 2 3 up more than 2 to 0. How much exactly it is? That's why in the practice, okay, because it depends upon the instrument, that is why student, any measurement, measurement, we write it this way. Understood? Z plus minus, maximum to minimum. Okay, now similarly, now let's say a when you measure, how we'll write? A plus delta A plus minus maximum value, the exact, the real value. Okay, the real value of A will be in between A plus delta A to A minus delta A. It carries that meaning, means the real value will be in between what? A plus delta A to A minus delta A. This carries the meaning. Okay, that's why. Similarly, in the measurement of B, we write it this way: B plus minus delta B. Okay, then what will be the, now A has some error, B also have some error, right? Then X will also have some error, right? Then how much delta X will be? Delta X will be addition of delta A plus delta B. This you need to keep in your mind. When we are doing the operation addition, then the error will also get added. This is the maximum error. Okay, maximum error. Okay, error, maximum error, this will be. Okay, now similarly, I can do quickly. If the operation what you involve is the subtraction, okay, is the subtraction. Okay, now you need to subtract, like temperature, you are measuring the difference of temperature, okay, from one reading to another reading. Now the difference, what you need to do, you need to subtract it, isn't it? So its operation is this. I'll take an example. Okay, then in that case also the maximum error will still be, we are talking about the maximum error. Okay, so the absolute error delta X is equal to delta A plus delta B. I hope it's so. Every time what is happening about the error, see, I'm writing it within the block. Okay, I'm writing it within the block. You need to remember it. It's get added. In minus also it is adding. In addition also it is adding. Okay, now let us take, so if you remember this thing for addition and subtraction, then we can solve simple numericals based on this. Okay, give me a moment. Suppose let's say one length what we measured, L1. L1 is equal to, oh, it's not writing well. 1 minute, student. Same pen I need to use. Say L1 is equal to 2.3 plus minus 0.1 centimeter. Okay, and L2 is equal to 5.7 plus minus 0.1 centimeter. Okay, then the question says, I think we can see it clearly. Then the question says L1 plus L2 is how much? Okay, these are the values, these are the errors, right? Fine, this is the maximum error for it, this is the maximum error for it, right? Okay, now L1 plus L2. Now what about the delta L? Okay, now for addition, delta L for addition is what? Delta X is equal to delta A plus delta B. This is the formula, right? Now in place of delta X, what is this? Delta L, right? Now delta A is what? 0.1 plus 0.1. This is how much? 0.2, right? Isn't it? This is all about the error, right? What about the values? What about the values? It is 2.3 plus 5.7. This is what? 7, 8, right? So this is what? 8.0 plus minus 0.2 centimeter. All right, so whenever this type of things is there, you have to treat the error separately. Okay, fine. So the uncertainty increased or not? See, L1 plus L2, what is the level of uncertainty? If you minus it, This will be what? 7.8 to what? 8.2. So the real value, the true value for this measurement L1 plus L2 will lie in between this. So this is a range. The real value will be between 7.8 to 8.2. It says that. Okay, fine. Now the same question if I do. All right. Now the question says, let's say you need to find L2 minus L1. Okay, L2 minus L1, how much? Okay, let's say the question say it's how much. You need to find the difference. Okay, then for the difference also, what is the formula about the error? You need to treat the error separately. For the difference also, if it involve operation minus, like if x equal to a minus b, then how much delta x is? Delta x is still a plus b, right? Yes or no? Then delta L will be what? Still 0.2, right? Now if you subtract it, 5.7 minus 2.3, this is 4, right? Then this is 3, right? So this will be what? This is 3.4. The numerical value separately. Plus minus, what is the error? Error still, it gets added. Okay. So if it is plus, whether it is minus, still you have to have the errors which are added. Okay. This is one thing. Now coming about the operation, multiplication, division. Okay. Now number 3. Number 3. If x is equal to, okay, if x is equal to a into b or a by b, same. Multiplication and division, for both, it hold the same thing. All right. In that case, what is the absolute error? The absolute error, okay, absolute error, I am not showing the derivation, I am not showing how it coming because it is not needed. You need to know how to apply it. The absolute error, okay, is, the absolute error is the relative error of A, relative error of B into X. This is the one. Okay, could you remember it? So you need to remember it. Okay, you need to remember it, student, this one. Okay, fine. Will you catch it? All right. So this is the one. Then what to say? We can have the numerical. Then the same thing, I can write it this way also. If I transfer this delta x, then this will become what? Relative error. Absolute error by its true value. Relative error of x is equal to relative error of A, relative error of B. Right? Fine. Now, if you multiply this thing by 100, this is relative error, right? Right? Then if you multiply it by 100, what it would be? Percentage error in x is equal to what? When we are doing percentage, we need to multiply with the 100 because here we divide it by 100, right? So, percent. Okay. So, this way also we can do it. Okay. So, if the error involves the multiplication or the division, the absolute error is given by this way. Okay. Then I will do the class question which is there in your note. All right. Let us do it, that question, the same question. Okay. Okay, this is the one. Now in that question, let's say, is the same the textbook question, notebook question I mean. This is 4 plus minus 0.4 meter and B is equal to what? 2 plus minus 0.2 meter. All right. Now we need to find its area. All right. Now area means what? Area is nothing, just length into breadth, right? Isn't it? Now length into breadth. Okay, area. For this we need to do separately, and for the error we need to do separately, right? For it, length into breadth is 8, but for the error, like we are interested in the error, right? Now coming about the error part. Okay, let's call this area. So the formula, this one, what it will be? Delta A in place of delta x. A stands for area. This equal to what? This is what? Delta L by L plus delta B by B breadth, and this is what? Then this is area, right? Now delta L is what? 0.4. Length is what? 4. This is what? 0.2. This is 2, right? Area is what? Length into breadth. This is 8, right? Then this will be what? 0.1 plus 0.2, 0.1. Then this is 8. Then this will be what? 1.6. That means in the measurement of area, the absolute error involved is 1.6 what? Meters square, because area should be in meters square, right? So what is the actual area? What should be the actual area? Actual area is length into breadth. For this is what? 8. Actual area length plus minus how much is the error involved in that? Okay, meters square. That means what is the range? If you subtract it, okay, then this will be what? 6.4 to the range of it is what? 8.6. So what does actually mean is that when you are doing that experiment, okay, when you did that experiment, the area, the actual area should lie in between 6.4 to 8.6. So in this range the actual correct value is. Okay, it carries that meaning. All right, the same thing I can do even in terms of percentage or relative error also. Okay, so absolute error is how much? 1.6, right? Can we do this? Because error can be represented in terms of percentage also, right? Percentage error, a relative error is what? Delta A by A is equal to delta L by L plus delta B, relative error, delta B by B. This is the relative error. Compare with the true value, isn't it? Right? Isn't it? The error by true value, error by its measure value, I can say that in this case, right? Then this delta L by L, this is what? 0.1 plus 0.1, right? So this is 0.2, right? Now delta A in terms of percentage, then can you see it? Then percentage will be what? Percentage will be what? When we multiply it with 100, right? And this will be what? 20%, right? So the correction in the area should be by 20%. All right, so this is that it means that. So the same thing even it hold for the division also, student. It carries the same meaning. Okay, so for 3 and 4 it will be the same. Okay, then one question is there in your text about in your notebook about the division. That means where you need to find the density. Okay, now the next it when it involve the powers. Okay, when it involve the powers, like suppose x is equal to, let's say anything. Okay, a to power, let me do just as your text, a to power p, b to power q by c to power r. Power it involve multiplication, division, everything. In that case the absolute error in x should be, okay, the power comes first, p, the relative error in a plus the power will come in the front, q. Okay, okay, then absolute relative error in b plus, though c is in the denominator, r when it goes up it will be minus, but that will not make any change. Okay, c2, this is r the relative error in C into X. Okay, this way it will become. Fine, can you see it? Okay, so the power will come in the front. Negative, there will be no negative. Okay, this is the formula you need to know. Then what will be the relative error? Relative error will be when I transfer this delta X down, then it will be relative error, right? P delta A by A plus Q delta B by B plus R delta C by C, right? Now when I do multiply it with the 100%, it will become the percentage error. All right, so this then with this can we do the numericals? Okay, we can easily do the numericals. Okay, like let me take a numerical. Okay, let me take a new I hope we understood this one, right? Till here and the end, right? Let's see. Question is, say the question is, 1 minute, student. The question is, let's say x is equal to, okay, x is equal to a to power 4, b to power 5, c to power 6. Okay, it's like this type of question is very common. Okay, where let's say a involved the error by 1%. Okay, a has an error. Okay, then b also have an error, let's say by 2%. Okay, and C also have an error by 3%. That means any experiment what it involve, that experiment need to use this formula. Okay, need to use this formula, and A already has an error. It is given in terms of percentage, 1%, B has 2%. Then what is the percentage? The question is, because it's given in percent, error in X. X will also have error. Yes or no? A has error, B has error, C has error. So X should also have an error, right? Fine. Then nothing, no numerical value. It's talking only just about the error. Then what is the absolute error in X? Absolute error in X will be what? Delta by A plus 5 delta B by B plus C to power 6 delta C by C. If the C if it goes up, C to power minus 6, the minus will not be there in the formula. Okay, it is coming from here. Okay, then this right into X, this is the one, right? Now if I transfer this X on the other side, it will go what? To the denominator. Delta X by X is equal to what? 4 delta A by A plus 5 delta B by B, the same thing I'm writing, C delta C by C. Yes or not? Clear, no? Now percentage it is given, right? Then this is relative error. In the relative error, when I multiply with the 100, this will be given by percentage, right? So percentage error in X will be what, student? This quantity multiplied by 100%, right? Now let us multiply it by the 100. Okay, let us do it. Then this will be what? 4 delta A by A into 100%, right? Plus 5 delta B by B into 100%, right? Another is what? Plus 6 delta C by C into 100%, right? This quantity is what? This quantity is percentage error in A. This is what? What is the percentage error? It is given in the question, it's 1%. Another is for delta B, this is the percentage error in B. This is what? 2%. And another is 3%, right? 6 into 3%, right? Now this will be what? This is 4 plus 10 plus 6 into 3 is what? 18. So 28, 32. So what is the overall error involved? The overall error involved in the measurement is by 32%. So student, you have to see these types of numerical. From the error, I can expect only this type of questions. Whatever we did it, it's an easy. You need to remember those formulas. Okay, thank you.